Assembly Language Tutorials, Chapter 6, Section 2. Advanced Procedures Part 2 is the continuation of the first part. So first part is important and then you come here. So that would make a more sense. And here we are actually going to talk about only one thing, recursion, like function calling itself. So the basic idea is you call a procedure, you save the EBP into the stack, override the EIP, our prologue, and then the epilogue that we have seen. So what's going to happen is, after you do the prologue, you process something, and then you call the same function again. So epilogue won't happen that time. So the function is calling itself. It will come back. So it will process something, and then again, if the condition is not satisfied, the epilogue won't happen. So it keep doing that unless there is a point later on. Like suppose we are going to trying to find a factorial of a number. So 5, 4, 3, 2, 1, 0. When 0 comes at this time, actually your epilogue will be executed, and that contains your return instruction. So you go back, and then you keep going back and back and back. So each time the recursion runs a function call itself, so it creates its own stack frame, and multiple stack frames getting created, and then you keep coming back towards higher memory address. So that's what the concept of recursion is. Function calling itself is actually creating its own stack frame. So let's see a demo. All these source code are available in GitHub for you to play around. So once you watch these videos, you need to download these POCs from the GitHub and watch this video, run these things simultaneously, and you would get a lot of clarity. And if you have any questions, you shoot me in the YouTube channel, so I would answer them. So this is a factorial. This is very simple assembly code. So here is a factorial. I'm pushing this num1, this is 5 into the factorial. So let's see that. Immunity debugger. Okay, I have all the breakpoints previously set here, so I have not built it again, so they are still there. F9. So this is our area where we landed, 2e. So this was our factorial function. Here we have done the push instruction, which is 5, and then this is the return address, this guy 27. So that's why you see 27 over here. I wouldn't iterate too much because I've already covered this and you are experts by now. So we are here. And now look closely. Now push EBP. Here we are doing the prologue part. So EBP is pushed, and move EBP, ESP, done. And then we are accessing 8. So EBP is, what is EBP now, which is 10, and 8 would be 18. So we'll get this one. This 5 will be loaded into EAX. That happened. The compare EAX is 0. If EAX is greater than 0, though this compare instruction we have covered in the previous videos, of course it is greater than 0. If it is 0, then JA jump to 140. So is this is 40. I need another debugger or some coloring I have to change. This is 40. It will jump here actually. So our instruction is here. So as you can see, that is grayed out. So I'll keep having the breakpoint there. So we will come to this line. From this we will come to this. So the EAX will be decremented. we already have 5 saved in the stack, so even if we lose EAX, it's okay because we could restore it later. Now EAX was greater than 0, so we take a jump 140. We come here. Now I am going to run that, so this 5 will become 4. It became, now we are going to push that EAX into the stack. So here we got 4. Now we had previously 5, now we have 4. You see where we are going with this? We are decrementing, we are saving the value of the number and we are decrementing it each time, and then we are pushing those values into the stack so that later on we could multiply them and find the recursion. That's the concept. Again, recursion happened because we jumped from here to here. You see, we are actually making call to ourselves. So if you see the source code, this is factorial and call factorial. So that's why we, after pushing EAX, we actually made the call. So this is our epilogue part. It didn't occur because we just came back. As long as we keep having this condition EX greater than 0, so we would always keep landing at this thing and we would run this. So in order to terminate, we have to come here at some point, that we will see. So for that, this has to be satisfied. So let's see that. Run this, run this. Keep looking at 003, 3, 2, one more time, decrement, push it. Now 0 is also pushed. Now our condition, this thing won't be satisfied. See that EX greater than 0, it's not greater than 0. Check. Now move EX1. So you saw the jump didn't happen there. That's why we came here. If you couldn't notice that, that line is actually grayed out because EX now is 0, which is exactly what it is. So we are here. So now we add 1 because we know that we have reached 0, so we cannot multiply something with 0 because it would become 0. So we add 1 and then short jump for C. So we come here. Exactly that we have here. Now we are going to execute the epilogue part. Return, and now we keep multiplying that. So EAX would be incremented. So now we have this guy, multiply EBX. Now EBX has 1, so 1 multiplied by EAX. Now mul EBX means whatever value we have in EAX, multiply that with EBX. So it is 1, pop, return. Now we have EX as 1, EBX as 2. So because of this 8. So now when we stored the things, so we stored them in a specific order, so which are offset by 8 bytes only. So each time we see that this thing keep changing, this EBX keep changing, and this get multiplied because of this instruction. So if you see here, over here 6, 18. So I hope you couldn't see that. I will rerun it. Actually our loop terminated. 4, look at this area only. 1, 0. Now the multiplication starts. 2, 6, 18. So now we are at 18. So hex, this is in hex, so you have to be careful. So hex in 18 means we are at 24. So 2 cross 3 cross 4. So we got one more to go, and there we have it. We have 78. So 78 in hex is actually 120. So we have our multiplication. So now our loop is actually going to terminate, and it's done. So that covers the recursion part, and play around with this thing. I keep iterating myself, so the more you play around, the more comfortable you get, and write more code, change things. You have already learned the concept, so change things and write a program on something else, like swapping two numbers, print, and having an array accessed in a reverse way, because right now we have not explored the Win32 API. That would come along soon. In that we will actually talk about how to take input from a assembly input, how to take user input, process it, and show that in the console. So we are here now. We cover string, and then here in the interfacing with high level languages, here we talk about API. This is where we'll see the output of all the things we have done. Right now everything we have is in the register only, it's not doing anything. So what good is a program if it doesn't ask for any input and produces certain output? So we'll get there eventually. So I hope you enjoyed the videos, and put comments, like if you have any questions, so put comments there, I would answer them. So and subscribe, so that it keeps me motivated, and you would get so awesome videos like this. And if you have any feedback, so do let me know that also. And have a good day.